Grade 12, we're on our 5th day of trigonometry and we're doing angles applications heading to related angles. So it's going to be a short one. Example number 1. If tan C equals minus 6 over 5 and angle C is in quadrant 2, find cos C and sine C. So again, our quadrants are 1, 2, 3, and 4. And we expect to see all trig ratios positive here. Cos is positive here, sine is positive there, and tan is positive there, our cast rule, which we've just kind of talked about in passing. So we're going to keep bringing that to your mind. Tan of C is minus 6 over 5. So if tan of C equals minus 6 over 5, and I know that tan is y over x, then I know my y value and my x value. X is 5, y is minus 6. So I have the point 5 minus 6. Except wait, 5 minus 6 is in the 4th quadrant. And we were told that angle C is in quadrant 2. So tan is negative in quadrant 2, and we expected that it would be. But when I have x is 5 and y is minus 6, I'm in the wrong quadrant. So if this is a negative ratio, then my x value must be negative and my y value positive, which would give me a negative ratio, and it would be in the 2nd quadrant. 5 to the left, 6 upwards. And we have our point. So angle C would travel through the point minus 5, 6. If tan C is minus 6 over 5, I have my x and y values, but I don't have my r value. The length from the origin to that point, minus 5, 6, I can use Pythagorean relationship on. X squared plus y squared equals r squared. And I will have minus 5 squared plus 6 squared, 25, and 36 is r squared, 61, which I'm going to leave as a square root. Remember, r is always positive. So I have my x and my y and my r. So tan C minus 6 over 5, or minus 6/5. It doesn't matter where that negative sign goes. Sine C is y over r, which will be 6 over root 61. Take a second to check, is sine supposed to be positive? Yes, it is in that quadrant. Cos, I expect, will be negative, and it is x over r, negative 5 over root of 61. We have found the 3 trig ratios with exact numbers using x, y, and r. If cos h equals 5 over 6, and h is in quadrant 4, so quadrant 4 is here. Sorry, 1, 2, 3, cast rule. There we are. And our angle of rotation is in quadrant 4. I know that cos h is 5 over 6, which is x over r. Does it make sense that your x value is positive in that quadrant? Absolutely. And your r value is positive always. So our y value that we're expecting to find is going to be negative. That's why the picture is worth 1,000 words. I don't have my y value. I can find my y value by using the Pythagorean identity. So x squared plus y squared equals r squared. My x value is 5. My r value is 6. And I need to find y. 25 plus y squared is 36. I'm going to subtract 25 from both sides. I'm going to get 11, which is kind of ugly. going to take the square root of both sides. But remember, I expect that y will have a negative value because I was told it is in quadrant 4. So negative root of 11. And that's also true that negative root 11 squared is 11. So it is a possible answer. We have our x, our y, and our r values. We can find the other two trig ratios. We have cos, we need sine, and we need tan. Sine of h is y over r. Our y value is negative root 11, and the r is 6. Tan of h, tan is y over x. Our y value is negative root 11, and our x value is 5. We have all three trig ratios. This is a question out of your homework. We're just going to do quickly together. It says that the coordinates of a point F on the terminal arm of an angle theta. Okay, so if we have an initial arm and a terminal arm that goes through F, and we have an angle of rotation of theta, and it goes through the point 86, we want to find the primary trig ratios for angle theta. So I want sine theta, cos theta, and tan theta. And I'm going to just keep in mind that that is y over r, x over r, and y over x. I know my x and y values. I just wrote on top of them, but my x is 8 and my y is 6. Does it make sense for both of those to be positive in that quadrant? Absolutely. And my r value is also going to be positive and always positive. And I can find my r value by looking at the Pythagorean identity. I have 8 squared and 6 squared is r squared. 64 and 36, 100. R is 10, and we expect it to be positive. I don't count the negative possibility. So sine of theta equals 6 over 10. Cos of theta equals 8 over 10. And lastly, tan of theta equals 6 over 8. All of those could be reduced. 3/5, 4/5, and 3/4. The next question states, determine the coordinates of the endpoints of the terminal arm for each angle. And the first one we're going to look at is, this is B, I, 180 minus theta. So this is the angle I want to look at, and I want to find the coordinates x, y of that terminal arm. So this angle of rotation, 180 minus theta, is when we go that far, where we've gone 180 degrees and backed up theta. So it's going to have some symmetry there. My picture's not super. But that would be the terminal arm of 180 minus theta. And I want to know what that point right there is. And don't trust my diagram because I did it freehand. These angles are related. They would create the same triangle where you have a run of 8 and a rise of 6. This has the same angle in the corner. So you must be able to make a run of 8 and a rise of 6. Terribly, terribly drawn. But that would be the point minus 8, 6. So for the angle 180 minus theta, we have the point minus 8, 6. And sine of that angle would be, just using blue to mark that one now, sine of that angle, which uses that point, sorry, this is the 180 minus theta that I'm referring to, but it uses this point, it would also be y over r, and both of those are positive. So sine of 180 minus theta is likewise y over r. It's the very same as sine theta. Interesting. Sine theta equals sine of 180 minus theta. They ask us to look also at the angle 180 plus theta. So let's get that on our diagram. So we have theta, which passes through the point 86. And 180 plus theta would be the angle of rotation all the way there, plus a bit further, goes through there. Again, don't trust my diagram. 180 plus theta. Again, the diagram is going to be similar to the one we have in the first quadrant, where you have an opposite side of height 6 and an adjacent side of length 8. This theta as well in the third quadrant will have an opposite length, or height rather, of 6 and an adjacent length of 8. Because it's the same angle, it must have that same proportion. So the point that the angle 180 plus theta must pass through, this point right here, would have those same numbers, but it's 8 to the left and 6 down. So the angle 180 plus theta has the same coordinates, but both of them are negative. Notice that the cos of 180 plus theta is equal to, well, cos is x over r, so that would be negative 8 over 10. Sorry, another flub. It's getting late at night here. Tan. There. Let's look at tan of 180 plus theta. Tan of this angle is going to be y over x, and y over x would be negative 6 over negative 8, which is the same as 3 over 4 when I reduce. Notice that tan of 180 plus theta is the same as our original tan theta. So we have two interesting things. Sine theta has the very same ratio as sine 180 minus theta. And tan of 180 plus theta is the same as tan theta. Lastly, they ask us to look at 360 minus theta. The angle 360 minus theta is in the fourth quadrant. In the fourth quadrant, where you've had an angle of rotation all the way around there, where you have an angle of rotation of 360 minus theta. What is that point? Well, that theta as well has an opposite side of length 6 and a width of 8, an adjacent side of 8, just like the one above it. And so this point would be 8 right, 6 down. For 360 minus theta, notice that cos of 360 minus theta, that angle of rotation, which is x over r, equals 8 over 10. Notice that that is the same as our original cos theta. So cos 360 minus theta is equal to cos theta. Those can be helpful to us, and we're going to look ahead at some of those. You can try some of these problems on page 6.